Welcome you all to the next new YouTube channel, and that is Spark Research YouTube channel. If you remember, previously it was Research Spark YouTube channel. Because of some technical reason, I have switched to this Spark Research YouTube channel. So this is Dr. V. Chandra from Department of ECE, and in this session we are going to cover the some topics from the course VLSI Design and Technology. Particularly, we will take the two topics from the unit third, that is both multiplier and NAND gate logic design. So let's see what is the booth multiplier. First thing is that why are we talking about the booth multiplier? Very simple, so that the processing time will be reduced because it will reduce the further number of steps to perform the multiplication. So how we are going to perform it? So see here, now suppose if you wanted to multiply any two numbers, then what is the advantage? So Qn, that is, the we are going to suppose like the multiplier it supports some values and the accumulator, then the SC, then Qn plus 1. So suppose Qr is your multiplier and the multiplicand in your M. So if your Qn plus 1 is like 0 0 or 1 1, then directly you are going to shift. No need to do any operation. But suppose if Qn plus 1 is 0 1, then A will be shifted by A plus M. And similarly, if Qn plus 1 is 1 0, then A will be shifted by AC minus M, and then we'll take the final operations. So how will this operation will be conducted? Let's see an example exactly so that we can have the better understanding. So here is the algorithm. So suppose we are going to perform the multiplication of 3 into minus 4. So first thing is that what is A? A always will start from all numbers of 0. Like how will know that how many of zeros should we take? So it will depends the number of bits. Since the 3, that is multiplicand, is of 4 bits, and also the multiplier is of 4 bits, that is minus 4. So 100 and minus is 1. So that is why we are going to do it in the 4 steps. So always the number of steps and the number of zeros will depends on the how many bits you are considering for your operation. So this is also called the radix 4 operation. So let's see how can we multiply the plus 3 into minus 4. Of course, answer will be minus 12. Let's see how can we get it. So start the total number of steps, definitely it will be 4 because number of bits. And now accumulator, that is A, will be the all 0 and the beginning. Then Q, what is multiplier? Q is 1100. This is the multiplier. And then what is the Q minus 1? Always will start from 0 only. Now see, this is your Q minus 1, and the last 0, that is last bit of your Q, is also 0, right? So it means that Q minus 1 and Q both are 0. So let's talk about the step 1. So since both are 0 0, so no operation. Why? Because both are 0 0, so directly it will come down, no operation. And in that case, your directly it will be shifted right now, A Q Q bar. So finally your A right shift, since this is 0, so 0 0 0, and then right shift by 1. So now this 0 will shifted here, and 1 1 0 0 1 1 0, and this 0 will be shifted here. Now what? Now Q0 is 0 and Q minus 1 is still 0. So both are 0. Again, no operation, right shift. Okay. So right shift, no operation. So this is all 0. And then here, now this 0 will be shifted here. 0, so that is 0 0 and 1 1 here, because now this 0 will be shifted at this position, that is Q minus 1. Now if you will check, then the Q minus Q naught is 1 and Q minus 1 is still 0. So now your Q naught and Q minus 1 is 1 0. So 1 0. Now this one Qn plus 1 is 1 0. So what will happen? Now the operation will be conducted in this manner, that is A will be A minus M. So let's see, A is equal to A minus 1. So A is what? A is your all 0 and minus m. M is what? So m is your multiplicand, that is 0 0 1 1. So here is 0 0 1 1. Subtraction will be 1 1 0 1. So a will be the 1 1 0 1. Now again, after doing this operation, again we have to shift right, right? So once we will shift right now, then what will happen? Here 1 1 0 1, it will be, it will become the triple 1 0, because there is another one at this position, that is q here, q naught. So this will be your triple 1 0. Then here now in this position, now it will be the 1, because the this one will be shifted, that is available in this a. So this one will be shifted, so now 1 and double 0. So this one is double 0, and then 1 last one, and last one already been shifted in the q minus 1. So now 1 is there. So now finally, what will be the result? So triple 1 0 from here, the this one triple 1 0, and then 1 double 0 1, and then 1. So this will be the answer. And final values after the fourth step. Again, the for further, now if you will check the q and q minus 1. So here this is q 0 and q minus 1. So both are 1. So further, both are 1 1. So no operation. So now for the final values is triple 1 0 1 double 0 1. So now this one, that is just convert triple 1 0 1 and this value into the binary number. Here all values, so no operation after arithmetic operation. So here it will be the final values, that is all 1. uh, Here once will shift in the right operation, so final values this one. So just take this radix 2, if you will convert them, you will get the final values, that is 3 into minus 4, that is equal to the minus 12. So how will you convert? So just uh, the ones complement, that is all 0 0 0 0 0, then 1 0 1 1, and then plus 1, you will get the minus 12 values. So in this way you can perform the Booth's multiplier for any numbers. Now let's take some more topics. So here is another topics, like how can we represent the inverter gate circuit. So here if you will see, then we are like there is a AND gate, a NOR gate. So NOR gate you can design using the PMOS and NMOS circuit. Okay, so how can we design? So you can see PMOS can be turned on if you will supply V in is equal to the 1, and V in is equal to 0. In that case you can the turn on and turn off using this V in. So basically, if you are turning on your PMOS, then what will happen? Your NMOS will be the turn off. In this case, your current, that is V, will be flow till here, and V naught will be the high. So if it is 0, then it will be high, and further if it is 1, means this will turn off and this is turn on. So again you are going to receive the 0. So that's why this is your inverter circuit. Similarly, exactly how can you design the different circuits? So just remember the combinations, that is the PMOS and NMOS. So NMOS always will be in series and PMOS in the parallel. So this is Y is equal to AB bar. Further, if you wanted to make it the AND gate, then what can we do? Simply connect your inverter circuit. At this point you will get the Y is equal to AB. Similarly, we can design the other circuits. So always remember the combinations, like in series, this will be the product, and here the parallel one will be the product. But similarly here, if you wanted to design Y is equal to A plus B, then here both will be in parallel, like NMOS in parallel A and B, and here it will be in series. So this is the technique to design. Thank you for listening. If you have any doubts, you may please drop the comment.